Yeah, once again, this is now Patrick Kamala, tutor educator, mathematics and physical sciences, grades 8 to 12, online. So now we are now doing question 6. This is a series of videos that like I told you. Now this question 6, we are gonna do it together. But as we do it together, please, I want you to watch it over and over again until you understand. Okay. Now they give us this equation g of x. They say the graphs g of x. They say the graphs g of c. Okay. Our g of x equals to what? X plus c, which you guys can see properly. Okay. Equals to x plus what? X plus c. Actually equals to 1x plus c. Equals to 1x plus c. So my marker equals 1x plus c here. Now that one there is the gradient. Okay. And then here we know, okay, they also gave us the hyperbola f of x. See this one here. They said that our f of x, which is the hyperbola, equals to what? Equals to a over x plus p. Okay, a over x plus p, and then they say plus q. Okay. Now they say that the graph g and the vertical asymptote of f intersect at the x-axis. So the two graphs intersect at this point here. Okay, and then what must we do? They say, so this is the hyperbola and this is the straight line g. They write down the coordinates of the x-intercept of g in terms of p. Okay, now as you can see here, our g, this is the x-axis, our g meets here, and this point here, it is the x-intercept of our g, but it has this point of intersection of the two asymptotes. So mean that this one is also p. So remember that our asymptote, they intersect at this point here. So this is our p here, this is our p here. So that's our p. So in other words, because they say they want the intercept in terms of p, our answer is going to be to p. X equal to p. Hope we are together. Till just the beginning of this question. Okay, so now they say that the graph of g intersect the horizontal asymptote of the graph of f at x equals to 1 and the graph f at x equals to 3. So at x equals to 1, we are intersecting the horizontal asymptote. So this point here, this x here is 1. Okay. And then they also meet again somewhere here at this point here. And they say here x is 3. X is 3 here. Okay. X is 3 here. I think let me just zoom in for you guys to see properly. X here. And then they say that they say here that and the graphs f and g intersect on the y-axis. Then we see the intersecting here. Determine the equation of the function f. Okay. So now here, guys, I want us to reason this together. What the equation of the intersection? I mean of the hyperbola. Now this hyperbola equation, our task is to find a, p, and the q. A, p, and the q. Okay. So what do we notice here? Now from the given information, we can see that this point they are on the same line here. Okay, so this point here, I'm gonna call it the point A. That's gonna be our point A. This is our point A. Okay, this is our point A here. Now that point A, it's the point 1 is to y1. The point 1 is to y1. I don't know the y value yet. Okay. Then this other point here, call it point B. This point B, it is 3 is to y2. 3 is to y2. This is our point A here. Okay. Now this point together with this point in the middle, they're on a straight line. Okay. And their gradient, if you remember our given equation g of x, they said g of x equals to what? Equals to x plus c, right? X plus c. And this is 1x, because there's one here. Now, if we have any hyperbola, like in this case one we're looking for, the f of x, okay, whereby our f of x equals to a over x plus p, like in this case they said plus p, and then plus q. We get our line of symmetry. Let me just put it here for argument's sake. Line of symmetry, the line of symmetry here, this one, okay, this line of symmetry, which I'm drawing now. Now, this line of symmetry, together with the given line g of x, they have something in common. They have something in common, guys. I don't know if you're gonna see it yet or not yet. Now, this line of symmetry, which has got a positive gradient for this hyperbola, has got the same gradient as the g. Hello, I repeat, the line of symmetry with the positive gradient, and one you see dotted, which is blue here, we're not given by our line of symmetry, given by y, okay, equals to positive 1, equals positive 1 into x plus p, then plus q, into x plus p, x plus p, and then plus q. Okay, so here, now somebody can say, why is that important? Now it is important because I want to find my coordinates y2 and y1 together with the p, but these lines have got the same gradient. So the gradient here is what? Is 1. It is g. They give us 1. Even here, from the theory, we know here also 1. So because the m is 1 and we have our g, we can use points A and B to find the change in y. So our point A, okay, our point A, which is 1 is to y1, and our point B, this is 1 is to y1, and our point B, which is 3 is to 2, okay, 3 is to y2. The gradient AB should be 1 because the lines are parallel, as you can see. So our MAB equals to 1, okay, equals to 1. But again, if I use A and B, I know same as saying change in y, and this is y2. You can say y2 2 minus y1 divided by what? Divided by 3 minus 1. Divided by 3 minus 1. By 3 minus 1 here. So my 1 equals to change in y, or you can say y2 minus 1. Now the 3 minus 1 gives me a 2. So when I cross multiply, my change in y equals to 1 times the 2. Now this is where the most important thing is here. Don't forget my target is find the equation of the f of x. I want to find the a, p, and q. Okay, so from here now, I can see that the change in y, with this arrow here, the change in y from this one here, my change in y, my change in y, okay, this one here, okay, this one here, I want to give it a red color so you can see it properly. Now the change is from point B here up to this point here, but this is point A, okay, So I want my change in y. Now this arrow which you see that is in a red color is our change in y, which equals to 2. Now to get this 2, because this one is above, I can say this one here, I'm at b, because I will get the 2, I can put a 1 here. I can put a 1 here. And then at this point here, because I want to get the 2, I'm going to put a negative 1. I'm going to put a negative 1. Why do I put a negative 1 here? Somebody can say like that. Because if I say 1 minus negative 1, 1 minus negative 1 gives me the 2. And 2 is what we got here. Okay. So in other words, my q, all of my horizontal asymptote is going to be negative. So for this question now, our q is negative 1. Our q is negative 1. Don't forget our task is to find the q, the a, and p. Okay, getting this now, and now point b is what? It is 3 is to 1. 3 is to 1. 3 is to 1. 1, okay. And so now I can find my c for the g of x, because they said that is 1x plus c. Guys, as you can see, because my g of x has a line at this point b now, I can say that g of x equals to x plus c, ne? Okay, don't forget x plus c, but it's passing through point b, right guys? Passing through point b, so I can get my c. Okay, at point b, my y is 1, my y is 1. Okay, what about the x? It is the 3, then plus c. Okay, so what's 1 minus 3? I get a negative 2 equals to c. Okay, so in other words, this point here is negative 2. Okay, that's negative 2. But now get my what? I want to get my p here. Now at p, because this is negative 1, this is 1, this is 0. And how do I get my p now? What do I know? How do I get my p here? How do I get my p? Okay, after getting our c, now our g of x is given by y, okay, equals to 1x, equals to 1x minus 2. But at the p, the same as the x-intercept, ne? What happens at x-intercept? We know that our y equals to 0, ne? So the x at p, if I put a 0 here, I'm gonna say equals to, which gives me x as what? X as 2. So in other words, the x equals to 2, which is the same as p. So far, I know the q and I know the p. So my f of x given by f of x, we can say y, okay? F of x, or we can say y, is to a divided by x plus p. But now I know my p is what? Is a, let me now x minus 2, okay? X minus 2, positive x minus 2, and then plus the q, what? Negative 1. So I'm going to say here minus 1. Now to find my a, the hyperbola is passing through the same point b here, which is 3 is to 1. So I'm going to use it now. That is 0.3 is to 1 here. 3 is to 1. So in here, our y is what? The y is 1. Next, I'm going to say that 1 to a divided by x minus 2, and then minus 1 altogether. So minus 1 become positive 1. So 1 plus 1 gives us a 2 here. Okay. Equals to a. Okay, I know the x is 3 here. What is 3 minus 2? X is 3 here, right guys? So 3 minus 2 is equals to a. So in other words, my a is a 2 because here x is still right. So after getting a as a 2, my function f of x equals to a, which is 2 divided by x minus a 2, okay, and then minus. Hope we are together, guys. That's what we have to do for the 5 marks. Yes, more can get us on 0785 222041. Now, lastly, here they say that describe the transformation that G must undergo to become an axis of symmetry of the function that cuts f at 2 points. Okay, now our G here is just above this point here. So if you can just translate it down from 0 to -1, that means by 1 unit, you're going to be sorted. So the answer here, it should be a translation, okay? Translation, that is by what? X is to Y, X is to Y. Now we are translating downward by 1 unit. So when we do translate by 1 unit, it's going to be, we subtract only 1, okay? It's going to be now Y minus 1. So that's our answer, because if you split it, you're going to be having our symmetry, this one which is in blue here. All right, thank you so much, guys, for watching. You consider subscribing for more tips and more tricks of such questions. Thank you.